Here's another equation that defines y as an implicit function of x, and we just want to find the derivative. So when we have an implicit function, we just take the derivative of both sides with respect to x. So if we take the derivative of the left side with respect to x, that's going to require the product rule. We'll have to take the derivative of x squared, which is 2x, times y, plus the first, which is x squared, times the derivative of the second. This is also a product, so we're going to have to use the product rule there. We'll take the derivative of the first, the derivative of x with respect to x is 1, times the second, which is sine y, plus the first, which is x, times the derivative of the second. The derivative of the sine of a function will be the derivative of the outside, which is cosine, evaluated to the inside, times the derivative of the inside. Over here we have a function squared, so the chain rule says you bring down the power, you get y to 1 power less, and then you multiply by the derivative of the inside function. Okay, so what I need to do is to get all the terms that have a dy dx, this one, and this one together on one side. And maybe I'll just bring all those over to the left, and then everything that doesn't have a dy dx, so this 2xy and this sine y, those can all go over to the other side. Let's see, this one's already on the correct side, but that one needs to come over. So let's see, when I do that, I have x squared dy dx minus x cosine y dy dx minus 2y dy dx. Bring those two over and we get minus 2xy and minus sine y. Now each of these terms has a dy dx, so it can be factored out. That would leave us x squared and minus x cosine y and minus 2y times dy dx. And we can finish this off by dividing both sides by what's multiplying dy dx. That will get dy dx alone. So we're going to have negative 2xy and negative sine y all over this, which is x squared minus x cosine y minus 2y. So we found dy dx. So in the implicit function, of course, the derivative usually ends up involving not only the independent variable x, but sometimes the dependent variable y there. So that's kind of the drawback of having an implicit function. You didn't have it solve for y to begin with, so you don't have the derivative in terms of, or you didn't have it solved for y in terms of x to begin with, so you don't have the derivative in terms of x in the end.